is linear functions. You'll be able to write equations of lines and graph equations of lines. Okay, let's take a look at linear functions. Linear functions have the characteristic that their rate of change, the change in y over the change in x, is always constant. Pick any 2 points on a line, and when you find that rate of change, it is the same. That is not true for a parabola, and that is not true for an exponential function. Slope. This is the definition of slope. We see it as rise over run, delta y over delta x, where we find the difference between the y's and the difference between the x's. The slope of the line is symbolized by the letter m. Let's go ahead and do some examples. In this example, I am going to take a look at a graph and try to find its slope. And I can see from this point to this point there is a change in y, which is -4. And there's a change in x, which is 3. So the rate of change in y is -4 over 3. Now let's go ahead and find the rate of change, the slope of the line between 2 points without graphing them. And so m will be equal, the change in y, 0 minus 2 all over -2 take away 4. And the answer is -2 over -6. Or 1 over 3. A lot of us can do this in our head, and that's okay. Pause the video and see if you can do the next 2 on your own, and then go ahead and restart the video. And here are the answers. Let's take a look at one of my favorite ways to represent a line, and that's called the point slope equation of a line. And notice that you need a slope and you need a point. And when you put them up together, then you have an equation of a line. Now, if you want to put this into your calculator, what you'll have to do is take this value and put it to the other side. And when you put it to the other side, it is now calculator ready. Parallel and perpendicular lines. In geometry, you learned that when corresponding angles are congruent, the lines are parallel. And in algebra, we notice that's going to happen when the slopes are equal to each other. For perpendicular, the slopes have to be opposite reciprocals. Okay, parallel lines have equal slopes. Perpendicular lines have slopes that are opposite reciprocals. And in numeric form, you can see 5/2 and -2/5 are what we call opposite reciprocals. Let's find an equation for this line. So I've graphed this line in slope-intercept form, and we have a point, and we'd like to find the equation of the line that goes through it. So I'm going to use my point-slope form, which is this, and I'm just going to substitute all my known characteristics. And so my y here is 5. My slope is the same as this line slope, which is 2, and then this is x minus 3. Now we can graph this. It doesn't have to go in slope-intercept form. You can actually just start from this point 3, 5 and just go up 2 units over 2 units, up 2 units over 2 units, or down 2 units over, and then go ahead and draw our line. And we'll find that that will represent a parallel line. Let's talk about finding a perpendicular line, okay? And here's my line that it's perpendicular to. I went ahead and put it in slope-intercept form so I could see the slope. And I know I'm working with an x-intercept of 6, which means I have a point 6, 0. All right, so remember that the point-slope form looks like this. And we're going to substitute our values in. So this will be y minus 0 is equal to, now remember, we don't want a slope that's equal, we want an opposite reciprocal, which will be 1/2, and then this will be x minus 6. Okay, and if I want to graph that, I'll just go over to this point and graph the slope up 1 over 2, up 1 over 2, or down 1 over 2, and I'll go ahead and I'll be able to draw the line. So in point slope form, you can still graph those lines. So the three ways that we write equations, and they're all useful in their different form, is point-slope form, slope-intercept form, and general form. Right now I'd like you to stop the screencast, see if you can fulfill all of these exercises, and then start the screencast to look at your answers. And that's it for linear functions.